So we're recording now, so I don't need to record another separate video. This is for example 3. Let's do this. Before we do this, let's talk about injective, surjective, bijective. So f is a function. So remember, we only talk about injective, surjective if it's a function first. Injectivity, you need for every y in B, there is at most one x in A such that f of x equals to y. You don't need this to prove anything, so you can ignore it. Basically, what we're saying is, if you have a graph here, this is your domain, this is your codomain, so this is your domain, this is your codomain. Then what do we have? Injective means you cannot have two things from your domain mapped to the same codomain. So this is not allowed. For example, like this. Oops, this is not allowed. This is not injective. So back to my terrible example where domain was a bunch of guys. Did I? So if this is a set of boys, and if this is a set of girls, okay, injective means, I think I did it the other way around, but okay. Injectivity means that you cannot have two, so a girl cannot date more than one guy, cannot date more than one boy. Okay, so if you have a girl who's dating two, if this girl has two boyfriends, then it's not injective. Okay, yeah, it was the other way around, right? I remember, because I said all the girls have to have a boyfriend, but all boyfriend not necessarily need to have a boyfriend, girlfriend. So it's a boy cannot date more than one girl. There we go. Changed back. So this is what we have. Injectivity means this. What's surjectivity? So this is not allowed, by the way. So let's leave it here. Surjectivity. So let's put those here. And remove this. So surjectivity, you have similar things. So domain, codomain. You have something like this. So for example, like this. And again, this is my girls, and this is my boys. Then surjectivity is saying that every single boy have to have a girlfriend. So surjectivity means no single boys. Oops. Okay, you can date more than one girl, but you're not single. So nobody can be single, but you can date more than one girl. That's what all it means. So for example, like this. This is surjective. It's not injective, but it's surjective. Okay, so that's what it means. Bijective is when you have a perfect world. So this means every girl has one boyfriend, is dating exactly one boy, and no one single. Okay, every girl is dating exactly one boy, and every boy is dating exactly one girl. Basically. Injective implies, surjective implies injective? No. for example, this one is not injective. So you have no single boys, but they can date more than one girl. Yep, they can date more than one girl. That's injective, surjective, bijective. Dating exactly one guy, and every guy is dating exactly. Okay, so that's what it means. However, when we prove, how do we prove? You look at this. So proof injectivity, you want this. You want for every x1, x2 in your domain, f of x1 equals to f of x2 implies x1 equals to x2. So this is what you need to, so this is for proof. Okay, for surjectivity, you need, where is it? Surjectivity. You need here, you need for every y in B, there is at least one x in A such that f of x equals to B. Okay. Yeah. Okay. So surjectivity is basically the second half of your image proof. So it's the same as second half of image proof. So I don't want to talk too much about it. Basically, it's the same thing. So let's try this question. Look at this question. I saw someone had a solution. Let me see. F1 negative y plus 1. But negative 1 plus 1 is not a natural number. You need them to be natural. So that doesn't work. When x is less than 0, when y is less than 0. Okay, so that's positive, positive. You get y. When y is less than 0. Well, we have there is a simple, easier way to do this. When y is less than 0. If you want to get negative number, it's actually something easier. So look at this. Let's look at this first. You want to prove it's surjective? Yes, you need to find your AB. So proof. Let's let y be from integer. And you need to find AB such that f of AB equals to y. That's correct. However, notice that this has to be natural number. This has to be natural number. You need to map to all the integers. So the easy part is map to negative numbers. Okay, map to negative numbers is easy. So for example, so if y is less than 0, then what can I do? Oh, I actually want it to be greater than 0, and I want to map to the positive or the negative numbers. So then, hold on, what do I actually want? Oh yeah, never mind. Then 0, I want it to be less than 0, sorry, because I want to map to a positive. Then 0, negative y. is from natural number, cross natural number, and f of 0 negative y equals to 0 square minus negative y, which will give you y. So this maps to, so whenever y is less than 0, we map to all the negative numbers. Oh yeah, you're right. 0 is not a natural number, so I cannot use this. What did I do? This is not a natural number. I should not use this. I should use, what do I want to use? Then your way will be good. We can have 1. Yeah, we can have 1 and negative. So we want 1 squared minus b equals to y. So y equals to, oh no, not y, b equals to, sorry. b equals to 1 minus y. And let's make sure this is right. This is less than 0. So minus 1 is positive. So 1. So this is, yeah, this is correct. So 1 minus y will be good. So this one is easy because you just need to fix one number. But the next part is harder because you cannot fix anymore. You want to map to the other non-negative number. So let me finish writing this. Minus 1 minus y, which equals to y. If y is greater than or equal to 0, what do we do? This is the harder part. You a and a squared minus 1. You should not have another variable because what is even your a? You should only have one variable in the element you pick for your domain. Then we get negative y, which is in that. No, but this does not match with what surjective means. You cannot have negative y, you need to get y. Does that make sense? Because surjective says for every y in B, there exists at least one element A in A for which f of x equals to B. You need f of x equals to B. So you need it equals to y. You cannot let it be anything else. Otherwise, you do not prove the surjectivity. So you want to pick something that's from the domain and f of this equals to y. So what do we do? Let b equals to 1. And what do we do next? A squared equals to y plus 1. But in that case, your a is not a natural number. Remember, a has to be a natural number. So what I'm thinking is this. So I want a, I want b, and it's a squared minus b. Oops, and it's a squared minus b. I want this to equal to y. So I want to get y eventually. A is squared. So whatever you put in here is going to be squared. So a squared, so for example, y squared minus something, eventually you want to get y. So I want another square here. So I want a y square here. If I have y square here, and if I put y here, then I have y square minus y square. and I want to equal to y, so I want to minus y here. So I have y squared minus y squared minus y, which equals to y squared minus y squared plus y equals to y. So this is what we have. However, if I do this, so if this is what I have, then what about 0? So this could possibly be 0, and this could possibly be 0. So it's still not wrong. So it's still not right. So I'm gonna add 1s to eliminate the 0. But if I add 1 here, then I have y plus 1 squared. This is y squared plus 2y plus y. You wanna minus something to get y, right? So you wanna minus what? You wanna minus y squared. And you wanna minus a y, sorry. So minus a y, so it's plus y. And you wanna, this is not y, this is 1. And you wanna minus 1, so you wanna plus 1. So in that case, my A is y plus 1, and my B is y squared plus y plus it. Yeah. So in this case, if I have this is a natural number, this is also a natural number. And if you plug in back to f, you will get y. So y plus 1, oh, and y squared plus y plus 1 is in natural cross natural. And f of y plus 1, y squared plus y plus 1 equals to y plus 1 squared minus y squared plus y plus 1 equals to y squared plus 2y plus 1 minus y squared minus y minus 1. So this cross out, cross out, cross out. So that's going to be y. Okay, so this map to all the non-negative integers.
Sorry, could you explain again how do you got a equal to y plus 1 and b equal to y squared plus y plus 1?
So, okay, before this, what I got was this. Before this, what I got was y and y squared minus y. However, this will give you y. However, in this case, your y can be 0, and this can also be 0. But we want natural times natural. So I want to get rid of 0. This could be 0. The smallest of it can be 0. So I know I need to add 1 for it to be natural number. So the smallest will be 1. So if A is y plus 1, so what? This minus B is going to be y. Then you can calculate your B. Does that make sense?
Okay, thanks.
Okay, let's see someone else. What if 1 minus y does not result in natural number? What do you mean? It's always natural number because this is a positive natural number, and 1 plus a positive natural number is also a natural number. Because you're y, they're integers, they're not rational numbers or something. So negative minus a negative integer will give you a natural number. Does that make sense? Okay, we'll stop here. Yes, basically, yes. So I want to show you something with 2 variables. That's all I want to do, because people are bad at 2 variables. But anyway, for those questions, you just need to try and work it out. There's nothing else you can do. There's no specific trick you can do. Okay, one specific trick is you can fix one of the variable you can fix it to be 1, but sometimes fixing 1 does not help either. So you need to try something like this. That's what I want to say, and that's the takeaway from this. It's not you got lucky, you're taking educated guesses. We have a logic here, it's not lucky. Yeah, you try fixing whatever you have. So it's just like what I did before. I had y and y squared minus y. I know, oh, this is not all the natural number has 0, so I will need to add 1 to get 0, to get rid of the 0. Study session tonight? No, I have something else to do tonight. So stop here because I have another tutorial. In my next tutorial, I'll do the rest of the questions. But bye for now.